Hello students, today we will discuss about linear inequalities in two variables. We will talk about how to solve linear inequalities in two variables. That is, we will see how to solve these linear inequalities in two variables graphically. Okay. So, what is the general form of linear inequalities in two variables? So, we know that linear equation in two variable is of the form ax plus by is equals to c. So, here linear inequalities in two variables is of the form ax plus by less than c or ax plus by greater than c, ax plus by greater than equals to c and ax plus by less than equals to c. So, these are the four forms of linear inequalities in two variables. These two inequalities are strict inequalities and these two are slack inequalities. That I told you in the previous class, inequalities in which less than or greater than symbol is used, that is called strict inequality, and inequalities in which greater than equals to or less than equals to is used, that is called slack inequalities. Okay. So, these are the four forms of linear inequalities in two variables. Now, we will see how to solve these linear inequalities graphically, the graphical solution of linear inequalities. Okay. Now, we know that when we draw a line in a Cartesian plane means xy plane. This is the xy plane. Okay. So, when we draw any line in this Cartesian plane, that line divides this Cartesian plane into two parts. Okay. These two parts are called half planes. As this xy plane is divided into two parts, so these two parts are called half planes. If the line is vertical, suppose I am drawing a vertical line here. Okay, then this vertical line divides this plane into two half planes. The right side of this line is called right half plane, and the left side of this line is called left half plane. Okay. So, when we draw a vertical line in the xy plane, this line divides the plane into two parts. There each part is called half planes, and here in this case, if the line is vertical, then this right side of this line is called right half plane and the left side of this line is called left half plane. So, when this line is non-vertical, suppose I am drawing a line in this xy plane which is non-vertical. Suppose line is like this. Now, this line is a non-vertical line. Now, this non-vertical line also divides this xy plane into two half planes. Here this line divides this xy plane into two half planes. Here the region above this line is called upper half plane, and the half plane below this line, that is called lower half plane. This is the lower half plane. So, when this line is non-vertical, this line divides this xy plane into two half planes, and the half plane which lies above this line, that is called upper half plane, and the half plane which lies below this line, that is called lower half plane. Okay. Now, we will see how to solve, what is the procedure to solve linear inequalities in two variables graphically. How to represent the solution region of these linear inequalities in the respective half planes. Okay. Now, let us see the procedure for solving linear inequalities in two variables graphically. Okay. Suppose the given inequalities is of the form ax plus by less than c or Ax plus By greater than C, or Ax plus By less than equals to C, or Ax plus By greater than equals to C. First of all, for solving these inequalities, we have to convert these inequalities into equation. That means we have to write the corresponding equation. So for all of these inequalities, the corresponding equation is Ax plus By is equals to C. So first convert the given inequality into corresponding equation. Okay. So that is Ax plus By equals to C. Now it is an equation. So next draw the graph of this Ax plus By is equals to C. So obviously this is a linear equation now. So the graph is a straight line. Okay, straight line. So we have to draw the graph of this Ax plus By equals to C. That means we have to draw a straight line. If this given inequality is an strict inequality, that is Ax plus By less than C or Ax plus By greater than C. If the given inequality is of the form Ax plus By less than C or Ax plus By greater than C, then draw dotted line for this equation, that is Ax plus By equals to C. Draw dotted line. We have to draw dotted line as here Ax plus By is less than C, not equals to C. That means the points on the line are not the solutions there. That means the points on the line does not satisfy this inequality. Okay. So if the given inequality is a strict inequality, that is it contains less than or greater than, then we have to draw dotted line. Okay. If the given inequality is of any of this form, that is Ax plus By less than equals to C or Ax plus By greater than equals to C, that is it is a slack inequality, then we have to draw complete line there. That means dark line or complete line we can say. Okay. Then so it means the points on the line, the points on this line Ax plus By equals to C is also a solution of this inequality. That means all the points on this line also satisfies this inequality, as it is greater than or equals to. It is equals to. Here also it is equals to, less than or equals to. So all the points on the line also satisfy this inequality. So in this case we have to draw dark line. Okay. So suppose I am drawing a line for these two inequalities, any of these two inequalities, that is if the inequality is Ax plus By less than C or Ax plus By greater than C, then we will get a line like this. We have to draw a dotted line in the xy plane. Suppose it is the line. Suppose this is the line. Now we have to identify the solution region. So how to identify the solution region now? To identify the solution region, we have to take a point in this plane. We have to take a point in any of the half plane. So it is better to take the origin as the point. Why? Because it is very simple to check whether this point satisfy this inequality or not. So we have to take a point in any of these half planes. Here it is the upper half plane and this one is the lower half plane. Now we have to take a point in any of these half plane to check whether this point satisfies this inequality or not. If the point satisfies this inequality, then the solution region of this inequality is that region which contains the point. If this point, suppose I am taking the origin now. If origin satisfies this inequality, that means this inequality is true for the point origin for 0, 0. Then we have to shade the lower half plane here. That means the solution region is lower half plane but not including the points on this line, because it is a dotted line. This line is drawn for the strict inequality ax plus by less than c or ax plus by greater than c. So we will take a point, so it is better to take the origin. So it is very simple to check whether the origin satisfies this inequality or not, but you should be careful while taking this point. This point should not lies on this line. This point should not lies on this line. If this line passes through the origin, then I will not take the origin there. You can take any other point. That means you have to take the point from any of the half planes. It may be from upper half plane or it may be from lower half plane, but it is better to take the point as origin. So if I am taking origin, if origin satisfies, if the point origin satisfies this inequality, then we have to shade that region which contains this origin. If this origin, if the point origin does not satisfy this inequality, then the solution region is that region which does not contain the point origin. That means in that case the upper half plane will be the solution region, but not including the points on this line. So whereas in the case of these slack inequalities ax plus by less than equals to c or ax plus by greater than equals to c, we have to draw complete line, we have to draw a dark line. That means the line may be like this, okay, and again we have to take a point either from the lower half plane or from the upper half plane, but it is better to take the point origin. The point which we are taking, that should not be lying on this line, okay. Then only we can identify whether this point satisfies this inequality or not. So if this point satisfies this inequality, that means if the point origin, if this origin satisfies this inequality, then here origin lies in the lower half plane, so the lower half plane will be the solution region. If this origin does not satisfy this inequality, then this region in which this origin contains, that region is not the solution region. So the opposite region, that is the upper half plane, will be the solution region. But here all the points on the line are also part of solution. All the points on this line is also a part of solution, okay, clear. So let us discuss this procedure using one example. Suppose the given linear inequalities in two variables is x plus y is less than 5. Now first of all, what we have to do, how to solve this inequality graphically? First of all, we have to draw the graph of the corresponding equation for this inequality. So what is the corresponding equation? Corresponding equation for the given inequality is, what is the corresponding equation here? X plus y is equals to 5. Now it is an equation, so we have to draw the graph of this equation. So obviously we are going to get a straight line, but here the inequality contains the symbol less than, that means it is a strict inequality. So we have to draw dotted line for this equation. So how to draw line for this equation, that you know, we have to find points, that means we have to find at least two values for the ordered pairs x comma y. So I am going to find the points now, just at least 2 points we know to draw the graph of this equation, that is x plus y is equals to 5. So just if I am putting x is equals to 0, we will get y is equals to 5. If y is taken as 0, then we will get x is equals to 5. So here the first point is 0 comma 5 and the second one is 5 comma 0, okay. We need at least 2 points to draw the graph of this equation. Now I will draw the graph of this equation, that is I am going to draw a straight line, but we have to draw the dotted line for this inequality. So mark the points on this Cartesian plane, that is the first point is 0 comma 5, so here it is 0 comma 5, and The next one is phi comma 0. So it is phi comma 0. Phi comma 0 is this one. Now draw the line for this equation x plus y is equals to 5, but we have to draw dotted line here as the points on the line is not a solution. Okay. So let's draw this line. So we have to draw dotted lines here as the given inequality is strict inequality, that is it is x plus y less than 5. Now we have to find the solution region. Solution region means all the points which satisfy this inequality, that is called the solution region. Now how to find the solution region? We have to take a point either from the lower half plane or upper half plane and check whether this point satisfies this inequality or not. If this point satisfies this inequality, then the solution region is that region which contains the point. Okay. Otherwise, the other region which does not contain the taken point, that region is the solution region. So it is better to take origin, as this line does not pass us through the origin. So we can take origin. Now take origin 0 comma 0 and check whether this point origin satisfies this inequality or not. Just substitute the value of x and y as 0 0 in this inequality. We will get 0 is less than 5, as 0 plus 0, that is 0 is less than 5. So it is true. That means clearly this origin satisfies the inequality x plus y less than 5. So origin lies in the lower half plane here. This is the line, dotted line, and this one is the lower half plane, this is the upper half plane. Here origin lies in the lower half plane. That means, and origin satisfies this inequality. So each and every point in the lower half plane lies in the solution region, as the point taken, that is the origin, satisfies this inequality. So here the lower half plane is the solution region and not including the points on the line. That means on the line there is no solution on this line, as it is less than. So we have to shade the lower half plane here. So the shaded portion represents the solution region. So finally we have to write the shaded portion on the graph represents the solution region excluding the points on the line. Here there is no solution on the line. Okay, clear? Now let us take another inequality, that is 2x plus y less than equals to 6. Now this inequality is slack inequality, as this contains the symbol, the sign less than equals to. So here the points on the line are also solution. Okay, so we have to draw complete line here. So first of all what we have to do, we have to convert this inequality into equation. So here the corresponding equation is 2x plus y is equals to 6. Okay, 2x plus y is equals to 6. Now we have to draw the graph of this equation. As we know, it is an equation, so the graph of this equation is a straight line and we have to draw complete line here, not dotted line. Okay, so first find the points on this line, that means the values of x and y. At least 2 points we need to draw the graph of this equation. So if we take x is equals to 0, if x is 0, then we will get y is equals to 6, very simple. Then if we take y is equals to 0, then we will get 2x is equals to 6. So it is x is equals to 3. Okay. So here the first point is 0 comma 6 and the next one is 3 comma 0. Okay. So mark the points in this xy plane. Now it is 0 comma 6, x coordinate is 0, y coordinate is 6, and the point 3 comma 0, here the x coordinate is 3, y coordinate is 0. Now draw a line passing through these 2 points, but here we have to draw complete line, not dotted line, as all the points on the line are also solutions, also satisfies the given inequality. So draw a complete line now. So this is the line, this equation 2x plus y is equals to 6 represents this straight line. Okay. Now we have to find the solution region, but we are given this inequality, so we have to shade the respective half plane. That is 2x plus y is less than equals to 6 is the given inequality. Now we have to check which region, the upper half plane or lower half plane, satisfies this inequality. So take the point 0, 0, origin. We can take any point, but this point should not lie on this line. So it is better to take the point origin. Okay, as this line is not passing through the origin, so we can take origin. So take origin and check whether this origin satisfies the given inequality or not. So just put the value of x and y. X is 0, y is 0, so we will get 2 into 0 plus 0, that is less than equals to 6 or not. It is 0. So 0 is less than equals to 6. It is true. It is true. That means 0, 0 satisfy the inequality 2x plus y less than equals to 6. 0, 0 satisfy the inequality. That means this inequality, this statement is true for the point 0, 0. So 0, 0 is a solution of this inequality. So we have taken this 0, 0 from the lower half plane, and this 0, 0 satisfies this inequality. That means the lower half plane is the solution region. That means the point, the half plane which contains the taken point, that means 0, 0 is taken now. So 0, 0 belongs to this lower half plane. So the solution region is the lower half plane. Now shade this lower half plane. Okay. So the entire lower half plane represents the solution region, and including the points on this line, as it is complete line now, because the inequality contains the symbol less than equals to, less than or equals to. So each and every point on this line is also a solution, and each and every point in the lower half plane, each and every point in the lower half plane is a point in the solution region. That means all these points, all the points in the lower half plane and on the line satisfy this inequality. This inequality is true for all these points in the lower half plane and on the line, points on the line. Clear? Next, take the inequality x is greater than minus 3. X is greater than minus 3. Here this inequality contains only one variable, and that is x. So first write the corresponding equation. Corresponding equation is x is equals to minus 3. Here if we take any values of y, we will get x is equals to minus 3. That means for any value of y, we are going to get x is equals to minus 3. So x is always constant. So we know that any line of the form x is equals to a, any line of the form x is equals to some constant is a vertical line, is a vertical line. If this a is positive, if a is positive, then this line x is equals to a, if a is positive, then this line lies to the right of y axis. That means right side of y axis. It is a vertical line and it lies to the right of y axis. Okay. Whereas if a is negative, then this line lies to the left of y axis. Okay. So here we got the equation x is equals to minus 3. Now how to draw the graph of this x is equals to minus 3? X is equals to minus 3 is a straight line, is a vertical line which lies to the left of y axis at a distance of 3 units from the origin. Okay, at a distance of 3 units from the origin, and it lies to the left of y axis. Okay, so here it is x is equals to minus 3. That means if we take any value of y, we are going to get x is equals to minus 3. So it is a vertical line. This is the line x is equals to minus 3. It is x is equals to minus 3. If we take y is equals to 1 here, then we will get x is equals to minus 3. If we take y is equals to 2, then we will get x is equals to minus 3. If we take y is equals to minus 1, then also we are going to get x is equals to minus 3. So that is why it is a vertical line. So you have to remember one thing, that if any line is of the form x is equals to a, then this line is a vertical line. Okay. So now what is the given inequality? Given inequality is x is greater than minus 3. So which region represents the solution region? One thing you have to remember here the inequality contains the symbol greater than. So we have to draw dotted line. Okay. So I am going to make it dotted now. So this is the dotted line, as the points on this line does not satisfy this inequality. Okay. So now how to find out the solution region of this inequality? This vertical line divides this plane, xy plane, into two parts. This part is the right half plane and this is the left half plane. So here it is very simple. Here it is given that x is greater than minus 3. So if we move to the right side of x-axis, then we will get x greater than minus 3. It is minus 2, minus 1, 0. Or we can take the point 0, 0, take 0, 0 and check whether 0, 0 satisfy this inequality or not. Just put x is equals to 0. 0 is greater than minus 3. So it is true. That means 0, 0 satisfy the inequality x greater than minus 3. Okay. But we can simply draw this region. We can simply find out this region, as we know that x is greater than minus 3 means it is to the right side of this line. Okay. So we have to shade now. The 0, 0 satisfies. So we have to shade the right half plane. Right half plane. So here this right half plane, the entire right half plane is the solution region, but excluding the points on this line, as the inequality contains the sign greater than. It is not equals to, so it is greater than. So we have to draw dotted line here. Okay. And here the solution region is the entire right half plane. So all the points on this right half plane represents the solution region. Okay. Clear? Now let us take one more inequality, that is y is less than minus 2. Y is less than minus 2. Here the corresponding equation is y is equals to minus 2. Y is equals to minus 2. So we know that if any equation is of the form y is equals to some constant, then it is a line parallel to x-axis. That means it is a horizontal line. So how to draw this line now? Y is equals to minus 2. I am drawing y is equals to minus 2. This inequality is less than, it contains the sign less than, so we have to draw dotted line. It is minus 1, minus 2. So y is equals to minus 2 is this line. This is the dotted line, and the given inequality is y is less than minus 2. So y is less than minus 2 means the value of y is less than, smaller than. So here if we take 0, 0, then 0, 0 does not satisfy this inequality, as 0 is less than minus 2. 0 is less than minus 2, that is not true. It is not true. And 0, 0 lies in the upper half plane. So upper half plane is not the solution region. So we have to take the other half plane. So here the solution region is the lower half plane. Okay. So the entire lower half plane, and excluding the points on the line. Here the points on the line is not a solution. So the entire lower half plane is the solution region. Okay. Clear? So that's all for today, students. Thank you very much.